All right, Year 11, I'm going to do one more from exercise 511, and I'm going to do question 5. I'm going to do this one here, F. This is a particularly hard question. I recommend you have a go at yourself and then come back and watch this and see if this doesn't help you find a way to sketch it. So let's start by writing the equation. And the equation is y equals 1 plus x on x squared plus 1. Now, I like to think about this as y equals, I'm just going to rewrite that another way, x squared plus 1 plus 1. Now, the reason I want to do that is because if I can sketch this, y equals x squared on x squared plus 1, I can then just move it up 1. So why don't I do that? Why don't I sketch y equals x on x squared plus 1 and then move it up 1. And the benefit of doing that is that if I can sketch this one, this x, I reckon this y equals x on x squared plus 1, that I'm going to be able to find out whether it's odd or even. It's going to be easier to find the intercepts. It's going to be easier to find the horizontal asymptotes, and if there are any vertical asymptotes, it's going to be much easier just to sketch that and move it up 1. So let's start having a look at what we can do here. First of all, there are no vertical asymptotes, none of those, because x squared plus 1 in the denominator never equals 0, because x is always going to be positive. So first, let's get some of the work out of the way. Let's find f of negative x. Well, that equals negative x on negative x squared plus 1, which is negative x on x squared plus 1, which is negative outside of x on x squared plus 1, which is negative f of x, which is an odd function, which is great. Half the work is now gone, and I can just draw half of the function, then rotate it 180 about the origin. Let's now have a look at when x equals 0. When x equals 0, I get y equals 0 on 0 squared plus 1, which is 0. So I get 2 for the plus 1. I get the x and y intercept. Let's go back here and find out if it's got any horizontal asymptotes. The horizontal asymptotes are the limit as x approaches infinity. And remember, I'm looking at just this x on x squared plus 1. So x on x squared plus 1. Okay, so we'll find the limit as x approaches infinity, and we'll divide by the highest power of x. So I've got x on x squared all over x squared on x squared plus 1, and that'll be the limit as x approaches infinity. That'll give me 1 on x on the top, and 1 plus, that should be 1 on x squared, 1 on x squared. Now, what will happen? Well, 1 on x will approach, as x approaches infinity, will approach 0. The 1 just stays, and 1 on x squared will also approach 0, so I get 0. So I have a horizontal asymptote at y equals to 0. All right then. So let's put an axis in and see what we get. And put in what we know. Well, we know that we have this asymptote at y equals 0. we know that it goes through 0, 0. Oh, well, this goes through an asymptote. Yes, sometimes they can pass through. Well, we know that it's going to approach 0, and we only have to concentrate on one side, because once we get one side, we're going to rotate it. We're going to rotate it 180. So we're only going to concentrate on x greater than 0 for now. So what happens? Well, we already know as x approaches infinity, it approaches 0. But from what side? What side does it approach 0? Does it approach it from this way? Or does it approach it from this way? Well, we don't know. Well, let's take a value. Let's let x equal 10. So y will equal 10 on 10 squared plus 1, which equals 10 on 101. And 10 divided by 101.099. And that means that it's not coming down from the negative, it's coming down from the positive. So we now know that our curve is coming down like that. Let me see, that's not very good. We've got to be very sure that it's continuing to approach 0. But somehow it's got to return to this point here, this 0, 0. So what happens? Does it do something like that? Does it do something like that? What does it do? So we're going to need some more values. And remember, you can just pick some values. So let's pick some values. We've already got 0, let's pick 1. Well, 1's over 1 squared is 1, plus 1 is 2. Oh, so when we have x equals 1, we get y equals a half. So I'm now going to start plotting some points. So, and I'm going to make that, I'm going to make that 1, but I'm going to make my axis here a bit bigger because I really want to see what's going on. So 1.5, about there. Let's try 2. So when x is 2, I get 2 over 2 squared, that's 4, plus 1 is a fifth. It's 5. So 2/5, about there. Let's pick 3. When x is 3. Well, 3 over 3 squared is 9, plus 1 is a tenth. Okay. Well, I wonder what happens when x is a half. Well, that'll give me a half over a half squared is a quarter plus 1. Oh, well, I better do a bit more maths here. So that's, I could use my calculator. A half over a quarter plus 1 is 5 on 4. And I know that I multiply by the reciprocal, so that'll be 1 on 2 times 4 on 5. That goes into itself twice, and that goes, 2/5. So it's the same there. Well, I think, and there's no way to tell, but maybe that 1.5 is as high as it goes. And then it starts coming down here. Now, you're not meant to know that yet. You don't have to know about where this is going to turn around. And there are some other things that you don't need to know yet either. I'm just going to do a better line than that. So it comes up, turns around, and starts coming down there. And somewhere along the line, the concavity is going to change. It's going to turn around. Now, luckily, we also know that it's odd. So this thing is going to replicate itself there. If we rotated that through 180 degrees through this point, that's what it'll look like. So now we know that the graph of y equals x on x squared plus 1 looks like that. But that's not what we were asked to sketch. We were asked to sketch up here this function, which is the same thing moved up 1. So we've done all the hard work. Let's now draw ourselves another axis. And let's put in the point. And remember, we want to make this pretty big. 1, and let's make that 2. And we're going to move it up 1. And we know it goes through that point if we move it up 1. And it comes down like that. And it comes down like that. It probably didn't go that high over here, but I'm going to let it go. And that's the graph of y equals 1 plus x on x squared plus 1. Now, if you were able to do that, if you were able to graph that function, that's brilliant. That's exactly what you need to be able to do. And you're beyond what I reckon most kids at this stage would be at. Anyway, good luck with the others, and I'll see you tomorrow.